Let's look at what happens when we treat roots like variables and like terms. Quick review. I'm going to have a real simple equation here. I'm going to have 7, let's do x minus 8y minus 5x. Now I did some color coding here. So we know the x's are in the same team. These are the same terms. 7x, take away 5x. I'm going to get 2x. And then I'm going to have the term that didn't have any friends. If I wanted to keep them blue, I'll keep them blue. Okay, so 7x take away 5x. I can do this same exact setup if I want to treat roots as like terms or variables. So I could have 7, let's do 7 of square root 3, take away 8, square root 5, take away 5, square root 3. Now, everybody likes to jump to conclusions here. They're like, oh, a 7 and a 3, that's going to be a 10, that's going to be a 21, that's going to be some combo of these two numbers. No, really what it's saying, it's 7 of these things. And this is square root 3. That's an irrational number. I don't want to think about it. I don't want to do that in my head. So I'm just going to count these. 7 of these things. And I have negative 5 of these things. So together, that's going to give me clearly a 7 minus 5 of those things. That'll be 2 square root 3, and then I get a negative 8 and a square root 5. Same exact setup. I have the same answer for both of these. Now, if I want to do a new example, let's do a more complex one. Let's go ahead and take 6 and then a square root 5 plus 2 square root 8, and then do a minus 6 square root 8 plus 2 square root 5. Just as before, well, now I have to do some interim steps. I need to distribute this, and that'll be 6 times this. And a lot of people like to say, oh, 6 times 5, that's going to be 30. No, don't jump to that conclusion. You're just saying 6 of these things. So 6 of my square root 5s plus 6 of my 2, so 6 times 2, that's going to be 12 square root 8. And then I have my same stuff I copied down. Now let's check for teams. I have team square root 5. I have team square root 5. I have team 8, and I have team 8. So my 6 and my 2, that's going to give me 8 of these guys. I'm going to have 8 square root 5. And then I'm going to have 12 minus 6. That'll be 6 square root 8. Final answer. Now, if I wanted to plug this in a calculator, I could get it to equal some nice irrational number, which goes on forever, dot, 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 dot. No fun. I don't really care. One final one, and this is going to be the challenge round. We're going to do some crazy ones here. 4, and we're going to take the cube root of 2. Man, that's ugly. Cube root of 2. And I'm going to say plus 2 cube root of 16. Now, on the surface, there's no like terms. This is cube root 2, this is cube root 16. But let's not forget that I can break this 16 down. So this part can be broken down to 2, and then I have 2 times 2 times 2 times 2. Still have the cube root here. This cube root, if we remember, is looking for groups of 3. So this guy is going to come out. So now I'm going to have 2 times this, not the 3, the 2 that came out here, and then times what's left over, this little poor guy who's left inside. Now cube root 2. What's 2 times 2? I got 4 and third root 2. Bring this plus down, bring all this stuff down, 4, and lo and behold, these were the same things. Add them together, I'm going to get 8 of these guys. And there you have it.